Hi everyone, this is the last video. I hope you stayed strong this entire time. I know each video is like half an hour long, and and that's troublesome to watch, but you can always, pro tip, you can always speed up the lecture if you want. I mean, you can skip around for one. For two, you can also do playback speed, right? And you can like put me on twice as fast if you want to, or you can slow me down, or you can pause, whatever works for you. That is the beauty of YouTube. All right, so we are on PowerPoint number 4 right now, so let me share my screen with you all. Alrighty, cool. Move myself over here for a change of pace. All right, so today, or right now, I should say, we're going to be talking about the double and half angle identities. All right, so we've already talked about the 5 fundamental types, right? Reciprocal, quotient, even and odd, Pythagorean, and whatever the last one was, I can't think of it, cofunction, right? And then we talked about the sum and difference ones. Now we're going to be talking about the double angle and the half angle identities. All right, so the objective for right now is I will be able to identify and utilize double and half angle identities to solve for the exact value and verified trig identities. All right, so notice we're doing a lot of different things here. We are able to identify the identity. We're able to use the identities. There's 2 different types we're going to be talking about, right? The double and the half angle. And we will also be talking about verifying and the exact value. So we're going to learn a couple more identities, and then we're going to do all the other stuff that we did so far in these past 3 videos, right? We're going to be doing that stuff to these new identities, okay? So here are all the identities so far. Perfect, great. Reciprocal, Pythagorean, cofunction, even and odd, quotient, right? I covered this up so it's actually spelled correctly now, and there were a couple typos, but I think I fixed those. So these are the 5 fundamental ones that we learned in the first video, or that we learned last Monday, right? These are the sum and difference identities. Okay. And now we're going to be talking about the double and half angle identities. All right, so we got the double angle. They're called formulas here on the sheet. Doesn't matter, it's same thing. All right, we've got the double angle identities here on the left, and we've got our half angle identities here on the right. All right, so notice, all right, I have these links here at the bottom. So if you want to know where these come from, right, like how we would derive these identities, you can click those links and check it out. I don't require that you know that. When it came to the 5 fundamental ones, I did want you guys to understand where those came from, and so we walked through those one step at a time. That's not so much necessary for the double angle formulas and for the half angle formulas, but just to quickly summarize, actually, here for this first one, right, sine of 2 theta, and notice, before I move on, notice that this right here, the sine of 2 theta and this cosine 2 theta, that is 2 times theta, right? That is 2 times theta. That is not sine squared theta. That is 2 times theta. All right, super duper important. That is why it's called a double angle, because we're taking the angle and we're doubling it, okay? So this first one right here, sine of 2 times theta equals 2 sine theta cosine theta, that actually comes from the sum and difference identities that we talked about from before. So that comes from that, and then the rest of these, I believe, come from the Pythagorean identities. Now, notice there's some blank spaces here. What that means is that here, right, we have cosine of 2 times theta. That equals cosine squared theta minus sine squared theta. And it also equals 2 cosine squared theta minus 1. And it also equals 1 minus 2 sine squared theta. So instead of writing it over and over again, they just left these blanks so you know that all 3 of these on the right here, pair up with cosine of 2 times theta. And then this very last one at the bottom here, right? Tangent of 2 theta equals 2 tangent theta over 1 minus tangent squared theta. Again, just like with all the other tangent identities, or at least when it comes to sum and differences, not super important when we're looking at double and half angle identities, just not very common. The most common use of tangent, right, when it comes to trig identities is when we're looking at the quotient identity and the Pythagorean identity and the reciprocal identity. Those are the main ones you guys have to worry about. I'm not gonna have you rack your brains over these tangent ones for either sum, difference, double, or half identities. They're not too important. So try to focus on sine and cosine. Like I said, I don't actually expect you to memorize any of these. This is not a good way, like a way to spend your mental energy or to spend your like brain storage, right? Like there's no use in actually memorizing these because you're not going to memorize them a year or two down the line. I don't think that's an important thing to memorize, right? So you guys are gonna be able to have the formula sheet in front of you, and I'm okay with that so long as you know how to utilize it, right? So long as you are able to identify and utilize. Notice, memorize was not part of the objectives, and it probably will never be part of the objectives, okay? So this is the double angle formulas. Hopefully you've been taking the time right now that I have been rambling to write these down. All right, we've got double angles on the left and then half angles on the right. Now these half angle formulas, they look super tricky, right? So we've got sine squared theta equals 1 minus cosine 2 theta over 2, right? That's a little ugly. We don't like that too much. And then we've also got some square roots up in here. Again, I think that the half angle formulas aren't super duper common when it comes to verifying, but we can use them to find the exact value. So we will try that, I think, maybe in this slide. If not, it's not going to be in the quiz, so don't worry about it. We'll mainly be focusing on the double angle formulas because I think those are a lot more useful and they're a lot more common. So I'm not going to have you guys waste your time on things that are not useful and not too common. Okay? So hopefully by now you've written these down. If not, pause now. I'm going to keep going. All right, so let's talk about finding the exact value here. I'm going to move myself a little bit out of the way. So up here, just like how we had before, we had the identities on top, and then we have our unit circle, right? Because we know to find the exact value, we're going to be taking a look at the unit circle. So let's say we're given this problem right here, 2 cosine squared of pi over 6 radians minus 1. Well, again, we're going to ask ourselves, just like how we have in the past, right? Just like how we have in the past, which identity pairs up with this? So we've got 2 cosine squared minus 1. Which one is that? All right. Oh, here it is. Surprise, it's almost like I knew. So we've got 2 cosine squared theta minus 1. That's exactly what this is here. So notice theta right here is in the parentheses right here. It's pi over 6 radians. That's our theta. And that is going to be equal to cosine of 2 theta. All right, right here we've got 2 cosine squared theta minus 1, 2 cosine squared theta minus 1, and that's going to be equal to cosine of 2 theta. And again, theta is given to us. It's right here, pi over 6 radians. All right, so all we have to do now is just plug pi over 6 into theta. Right, so we got cosine of 2 times theta, so 2 times pi over 6, which is 2 pi over 6, right? 2 times 1 pi over 6 is 2 pi over 6, and we can simplify this by dividing both the numerator and the denominator by 2, right? So then the numerator will become just 1 pi, right? And the denominator will become 6 divided by 2, which is 3. So then we'll get cosine of pi over 3. Now, if we take a look at our unit circle over here, we're going to find pi over 3 radians. It's right here. It's 60 degrees. And cosine, remember, is the x value in the coordinate point, right? X comma y, cosine comma sine. So our cosine value is going to be 1/2. And that's all. So this complicated thing right here at the top, 2 of cosine squared, pi over 6, minus 1, this complicated thing right here is just equal to 1/2. You see? This is something that technically, right, you would have been able to get the exact answer on the calculator because 1/2 is just 0.5 in decimal form on a calculator. But not every answer is going to look like that, right? Sometimes, like I could have asked you for sine of pi over 3, and then the answer would have been root 3 over 2, and that wouldn't have been so nice, right, on a calculator. Okay. It's storming a lot right now, and so like it's all crickety around me, like the windows creaking, the ceiling is creaking. It's kind of distracting, a little bit spooky. All right, let me continue. So hopefully we've written all of this down. Oh, there you go, 1/2. Okay, so let's find the exact value using one of the half angle formulas now. So I'm not sure why I didn't put the unit circle at the bottom here, but that's okay. I'll just reference the last slide to find it. Let's say we're given this problem right here, the square root of 1 minus cosine of pi over 2 divided by 2. Right, so let's take a look. Let's try to find this, right? We've got square root, right? So we're going to be looking at either this first one, this fourth one, or this last one. And then we got 1 minus cosine theta, so which is pi over 2 radians, right? So 1 minus cosine over 2. All right, right here. Right, this is 1 minus cosine. This one is 1 plus cosine, so we know it's not that one. And then this one has 1 minus it over 1 plus. It's definitely not that. So it's going to be this one right here, this second half angle formula, or this second half angle identity. Right, so we got sine of theta over 2 is equal to the square root of 1 minus cosine theta over 2. So here we have 1 minus cosine theta over 2, and take the square root of all of that. So this is the one we're going to be looking at. Perfect. So now we can identify theta, right? We know that that's pi over 2 radians. All we have to do now is take that and plug it right into here, a sine of theta over 2. All right, this is going to be a little bit of math, but bear with me, right? So we've got sine of pi over 2 radians, that's our theta, that's our angle, right? Divided by 2. We're going to do keep, change, flip, just like how we did in the past when we were talking about some other stuff. I don't remember which PowerPoint I discussed keep, change, flip in, but that's okay. We're going to keep the fraction in the numerator, right? So pi over 2 radians. We're going to change this operation from division to multiplication, and then we're going to flip. So 2, which can technically be written as 2 over 1, right, is now going to change to 1 over 2. All right, and then we're just going to multiply across. So we've got pi times 1, which is just pi, and then 2 times 2, which is 4. And again, we're doing sine of that. So we're doing sine of pi over 4. All right, so this big, complicated thing right here is equivalent to sine of pi over 4. Now let's take a look at our unit circle right here. Let's find pi over 4. It's right here. Same thing as 45 degrees, right? So we've got x comma y, cosine comma sine. So if we're looking for sine of pi over 4, it's going to be right here. Root 2 over 2. Okay, there it is. Sine of pi over 4 equals the square root of 2 divided by 2. Okay, so this big square root right here is just equivalent to root 2 divided by 2. Simple enough, okay? Now, let's try to do some verifications with this, okay? So we don't have to look at the unit circle. We're not finding exact values. I'm also not gonna have you do verifications for the half angle identities, only the double angle ones. So let's try. We're looking at this formula right here, all right? Sine squared theta plus cosine of 2 times theta, it's not cosine squared, it's cosine of 2 times theta, is equal to cosine squared theta. Okay. Well, notice we've got cosine of 2 times theta. So if you see 2 times theta anywhere, that should automatically set an alarm in your head that we're talking about a double angle identity because we're taking the double of the angle, right? So let's take a look at our formula sheet right here, right? We got the double angle formulas and we got cosine of 2 theta right here, right? So we can take this piece of our little equation and we can substitute it. Notice, I'm working on the left side of the equation because the left side is more complicated than the right side, right? So now let's look. We've got cosine of 2 theta and we've got 3 different options here. Now, we have to ask ourselves which one's the most useful option. Okay, well, if we see we already have cosine squared theta, and we already have cosine squared theta, and we also have sine squared theta in our formula. So maybe we should stick to this first one right here that talks about cosine squared theta and sine squared theta. So let's do that. Let's take a look right here at this, and let's replace that with this first cosine of 2 theta identity right here, right? So we're going to be substituting this cosine of 2 theta with this half of the identity right here, cosine squared theta minus sine squared theta. So it's gonna look something like this on the left side of the equation, right? All we did was replace this part in the red, right, with the other half of the identity. We just replaced it right here with this latter half of the identity, right? We substituted it. And now notice, we've got a positive sine squared theta and we have a negative sine squared theta. Those are going to cancel out, and all we're going to be left with is this cosine squared theta in the middle. And now that all we're left with cosine squared theta, right, for the left side of our equation, we've gone full circle and we have made it equal to the right side of our equation. So cosine squared theta equals cosine squared theta. And we did it. You see? So this was a simple one. This was only 3 steps. All we did was identify the double angle identity, and then we substituted it in. The signs canceled out, and cosine squared theta equals cosine squared theta. That's all. Okay? And they're not going to get too much more complex than that, especially for the quiz, right? The quiz, we don't have a lot of time, so I'm not going to have you guys do something that takes 20 steps. Okay. And also, again, I wouldn't really do verifications with the half angle identities. I don't think that they're really needed for the scope of this class. So just, that's one less thing to worry about. Okay. So we should have finished all of the PowerPoints at this point. Hopefully you guys feel comfortable doing the worksheets now. Hopefully you feel a little bit more able to do the review guide. And the review guide, like I said, is going to make you more than well enough prepared for the quiz. All right, so if you did work on the review guide, kudos, good job. If not, you should, because it's going to help you a lot. And if you turn it in, it is extra credit. So let's say you did the work, but you didn't do so hot on the quiz. Well, you're still going to get extra credit from the review guide, right? I want to give you guys ample opportunities to boost your grades. I know that this is a hard subject, and I know that we're going through it pretty quickly, but you guys do have the opportunity to boost your grades, and you guys just got to put the work in, and you guys are going to do great. Okay, so with that being said, I actually have written down like some of the answers and stuff for the homework assignments. I'm deciding whether or not I want to post something explaining that. We'll see, but at least we've gotten the actual like unit PowerPoint videos out of the way. So now all of the content itself, aside from the worksheets, all the actual content, course content material is now in video form. So we did it. Good job on unit number 4, guys.